Okay, if the aquarium is good to go and everybody else in the audience is good to go, we're going to get started because I anticipate Dominique and Frank joining us here very shortly. I want to welcome you to this special live event. We're excited to be celebrating Earth Day. Earth Day is, I think, on the 20th or so, but we're getting a jump start with it here on this weekend. This presentation is going to be about Antarctic Ice Stream Dynamics. We have a PolarConnect teacher, and I'll explain what that is in a moment, Dominique Richardson, and she's working with a very wonderful research team looking at the ice stream dynamics, which we're going to all hear about. And they're aboard a research vessel, the Nathaniel B. Palmer, someplace in the Southern Ocean. We'll hear about where they are. In North America, it's April 18th, 2015. As I get started here, I want to point out that my colleague, Sarah Bartholow, is also online on the chat room. And if you have any issues as we go through, please send technical issues or questions, and Sarah and I will try to keep track of that as we go through. This is Janet Warburton, and Sarah and I both work for Arcus. We're the company that hosts PolarConnect program, and we're based in Fairbanks, Alaska. However, today's host, Sarah and myself, Sarah's in Denali National Park in Alaska, and I'm in Anchorage, Alaska. So just to give you an idea of where we're coming from. For those of you that have been following Dominique in the crowd, this is Dominique, and this is her aquarium that she works from. She works out of California. She'll explain more about herself when she joins us here in a little bit. Today's platform is called Blackboard Collaborate. And you can see that the slides, I hope, have been changing for you in the center. The aquarium, just let us know if the slides are not changing for you, and then we can, again, troubleshoot for you. I know you got some bandwidth issues going on there. If you have joined us by just virtually and are using the computer for a microphone, you can ask your questions at the end of this event live and talk to hopefully Dominique and Frank and whoever else they have on their team by clicking the talk button once to open your mic and click it again to close it. If you've joined us by phone, you can unmute your phone and just interrupt us and say, hey, I have a question. That way we'll know that you have questions. And then you can see the list of participants. And again, if you're joined us virtually, you can chat with us online and post your questions in the text box below. And for phone participants, including the research team, we will relay questions. I'll try to remember to relay the questions so that you know what the questions are that are showing in the chat box and what the answers are. Another thing we wanted to share with you is if you are a participant and you are with us online, you can tell us where you're from. And I'm just going to pause here. Is that the research team from the Palmer?
Yes, this is Dominique and Frank calling in from the Palmer.
Excellent. Welcome, Dominique. I have the aquariums on, and we have a great list of participants that are starting to join us. And I've just started going over the very intro slides. I'm going to do PolarConnect next, and then I'm going to jump straight into you. Is that okay? Over?
Sounds wonderful. We will wait for your cue.
Excellent. Okay. I want to get started. If you haven't noticed, Dominique and Frank have a delay with their satellite phone, and they may sound kind of funny sometimes, but they will only be connected with us probably 5 to 10 minutes at the most, disconnect and reconnect. So we're planning on that kind of scenario. This next slide is about PolarConnect. Dominique is part of a professional development experience where we put teachers and informal educators such as herself with researchers such as Dr. Frank and in the polar regions. And we've been doing this since 2010, and we've been placing teachers all around the polar regions so that they can learn about science and get their hands-on feel for science and bring it back into their classroom or wherever they work. And that's why she is down someplace near the Southern Ocean, which I said we will hear about in a moment. So I'm going to turn this over to Dominique and the team. And Dominique, I'm on your very first slide that introduces the team. Over.
Thank you, Janet. I just want to go ahead and say hi to everybody at Cabrillo Marine Aquarium and everybody listening at home. I hope everybody is having fun at the Earth Day Festival. I know it's afternoon for you guys, but if I get confused and say that it's morning, it's very, very early morning for us over here. It's the middle of my night right now. And with me, I have Dr. Frank Michi, and I'm going to go ahead and let him say hello very quickly.
Yeah, hello everybody. It's great to be part of this PolarConnect event and have the opportunity to explain what we're doing here on the ship in the Southern Ocean to everybody.
So we have a lot of different scientists joining us on the cruise right now. So besides Frank and myself, we also have quite an international team. We have people from not just the United States, but from Portugal, from France, from Argentina, as well as Australia. So this is a true Antarctic cruise with a lot of team working together. And Janet, if you go ahead and head to our next slide in East Antarctica, I kind of want to explain where we are. So Antarctica is in the south. That's where the South Pole is located. And right now, we're over 8,000 miles away from Cabrillo Marine Aquarium. And you can't actually get straight to Antarctica. You have to go through someplace else first. So we happen to go through Hobart, Tasmania, which is that island to the south of Australia. And after going through there, we got on board the research vessel, the Dominique Richardson, and headed south to East Antarctica. And I know a lot of people might be wondering where East Antarctica is. If you take a look at the map in the bottom right-hand corner, East Antarctica is that kind of large, rounder part. And Frank has made a map to show where in East Antarctica we're going to be, and that's the red track lines and the yellow boxes that are there. There's several different glaciers in this area that we're going to be able to collect data. And the yellow boxes are the ones that we tended to go to, but this is field research. Things are always changing out here. So we've actually gone to the Dibble Glacier and the Totten Glacier so far, where we've been collecting lots of data and mapping the area. And we're spending this whole time on the research vessel, Nathaniel B. Palmer. So if you head to our next slide, Janet, you can get a beautiful look at the ship, and then of course my selfie with the ship that's there. And this is a very comfortable research vessel. It's one of the nicest that's around, and all of the crew and they tell me that we're lucky to be able to be on this ship that's out here. We have a wonderful crew and a great ice pilot there to get us through these very thick areas of ice that we're in. And there's a lot of ice in the area at this time of year. And it's a great way to travel, and somehow we got lucky and we actually get our own rooms on this trip as well. If you head to the next slide, I'm going to go ahead and pass it over to Frank to explain a little bit about his research. And I just want to check in now, Janet, and hear from you really fast to make sure you guys can still hear us and the sound is coming through okay.
Yes, we can hear you great, and it's coming through okay. A little bit of static, but nothing bad. Over.
All right. Here is Frank to talk a little bit about the research on the Ice Stream Dynamics page.
Yeah, thank you, Dominique. So just want to give you a little background information about what we're actually doing here in East Antarctica. So if you look at this map, it shows a picture of Antarctica and the nice satellite image below. you can see some detailed image. So the ice in Antarctica is not just one static mass. There's actually like streams of ice flowing from the center of Antarctica towards the coast, which are basically a big form of flowing glaciers, and they transport the ice from the inner part of Antarctica to the coast, where then the ice is carving out in form of icebergs, or it's melting. And if it's melting faster or carving more, then new ice is formed in the back of the Antarctica. Then the ice is thinning in general, and if there's more snow falling, then it's flowing slower, then basically the ice is thickening. And the map on the right, the different colors, shows you areas in Antarctica where it's actually thinning, where the ice is getting thinner. So that's more, the ice is flowing faster and it's melting more at the edges or calving more. Then new ice is formed. And in blue, there are some areas where we have more snowfall. Then it's actually melting. And so you see in the West Antarctica on the left side, basically some red dots, which shows us that the ice is thinning there, and it has been observed for a while. And a lot of studies are going on there. For a long time, we saw that the eastern part, the side on basically the right side of Antarctica, if you look at the map, was considered as being more stable. But there seems to be now some areas where, especially like the little red dot between like the C and C prime and D, basically in the right side of the map, which is the Totten Glacier. There seems to be some glaciers, some ice streams that are also, some areas that are thinning, so they're losing more mass. And the question is, what is going on in these areas? Are they having or experiencing similar processes than the ones in the rest? And all these measurements is basically done by satellites. They measure the elevation from the satellite to the ice sheet, and they see if it's getting thinner or thicker. But we actually have to go there to find out what actually is going on. So if we go to the next slide, it's just a zoom in to East Antarctica and some details about the Totten Glacier on the left. There was a recent article just coming out like a month ago from a Greenbaum group, from a Texas scientist that did measurements from airplanes and discovered that the Totten Glacier is sitting. So what he's looking there is like a topography, the depths of the land under the ice. And from an airplane, they can use the radar and look through the ice and see how deep the ice is and what's underneath. And they found this deep blue, so this deep trough where the Totten Glacier is sitting. And one of the questions we are looking at on this cruise is if this glacier or other glaciers in the area, if they're like sitting in a deep trough, can warm water get to these glaciers from the ocean and enhance melting, and could this be the cause why we see this thinning? We go to the next slide. It's a schematic basically showing how the general hypothesis is now, what scientists now thinking might happen to these areas where we see this thinning of the ice. So in general, we have a shelf break. That's the edge of the continental shelf around Antarctica. This is often shallower than the water depth near the ice. And in some places we have warm ocean water that might, and warm is just meaning above the melting temperature. So this warm water is still only like 33, 34, 35 Fahrenheit, like 1 or 2 degrees Celsius warm, and so this warmer water, relative warm water, gets over the shelf break, and it has a high salinity as well. That might be able to travel down into some depressions or troughs on the continental shelf, and might reach the base of the sheet or ice shelf, and if the warm water contacts the ice, it causes melting in the area. And the more of the ice is exposed to the warm water, the more melting is happening. So one of the goals of this expedition here is basically to find out like how deep is the opening at the shelf break. Is there a trough leading towards the ice? How deep it is, and do we actually see warm water near the shelf break or on the continental shelf as well that might cause some of the melting? And we're planning to compare different ice streams or glaciers along the Antarctic and trying to see what's going on in the different pieces. And I'm going to go back to Dominique, and she's going to talk about the different techniques he's using.
Yeah.
Hello.
Yes.
We're
Dominique,
still here. Let me go ahead and check in with you.
Yes, thank you. We do have questions that I'd like to relay right now. First question, how cold is it? Second question, how can you tell what is under the shelf ice? Over.
Those are good questions. It is right now. It is minus 12 degrees, but Celsius. But I'm inside an office, so it's not that cold in the office. It's maybe 60 degrees Fahrenheit inside the office. And the other question, so we're going to know what's under the ice. It's the perfect question because it's going to lead us right into our next few slides. Janet, if there are no more questions, I'll move on to answer that person's question and talk about how we find out all of this data.
No more questions, but I did want to relay to you that there's about a good group of people listening in at the aquarium and about 40 others that have logged in. So we just wanted to relay to you that there's a good crowd out there. And I don't see any other questions, so we can go to the next slide after ice stream dynamics that Frank was talking about. Over.
All right. We will head into research techniques, but I also just wanted to mention that all of this work that Frank and his research team are doing, it's wonderful that they've let me help out with this and get some hands-on experience doing this type of research. And a huge thank you to NSF, who's been able to fund all of this that we're doing down here. And it's incredibly important research because East Antarctica holds a huge amount of ice, and learning both the speed which areas are melting or the risk that these areas are melting impacts all of us, even back in Los Angeles and in areas across the world, because there's so much of this water ice that's out of the ocean. As it melts, it can impact sea level rise. So the work that Frank and other researchers out here are doing is incredibly important to all of us. So it's important for us to know how they're able to get this information. And we're using a variety of different pieces of equipment and different research techniques to discover these deep water troughs, if they exist, where they exist, to study the water and find if there are these warm water masses, where they are they up on the shelf, are they close to these glaciers. So one of the first techniques we're using is multibeam bathymetry. And basically we're studying the topography of ocean floor, and we can look at what things look like under the sea ice, under the water. And the way bathymetry works, it basically sends sound out from the ship. And when you're sitting on the ship, you have really good hearing. You can listen and hear tiny little pings going off. It's really high pitched. And these pings come from the bottom of the ship, and they go down towards the bottom of the ocean, and then bounce off the ocean floor and come back to sensors on the ship. And on the ship, there's special programs that help coordinate where the ship is moving, how much it's moving, how fast it's moving, how much it's pitching and rolling. And then the computer programs basically can do some math to figure out how fast those sound waves return back to the ship and figure out what the topography of the ocean floor looks like. And so we'll put back a whole bunch of little dots that can tell us as we get through and edit and look at the data what the bottom of the ocean floor looks like. We can find areas where past glaciers have moved and channels where glacier water has run past before, and to see other features of the ocean floor that are under the ice down here. And we're using that to be able to look at the slope as well as the slope of the continental shelf, as well as areas glaciers have been before. And one of the very cool things that we are doing with this multi-beam bathymetry right now is we are mapping areas of East Antarctic continental shelf that have never been mapped before. We are going into areas where people haven't had the chance, or they haven't been here since they used the technology, and we're going to areas where some people have never been before. And part of the stuff that we're doing is creating this map that will be available eventually to everyone of what the East Antarctic look like. Let's go to the next slide. So we can use that bathymetry to find those troughs to map the ocean floor, but we also need to look for that warm water. And one of the ways we can do that is using something called a CTV, which is a piece of oceanography equipment that CTV stands for conductivity, temperature, and depth. And on the left-hand side, you can see what a CTV looks like. It's a very tall, well, at least the one that we have on the ship, is a very tall piece of equipment. It has a lot of sensors down at the bottom of it that can measure salinity, they can measure pressure, they can measure depth and temperature. They can also measure the amount of oxygen in the water and fluorescence to tell us stuff about the plankton and the life that are in the water too. And then at the top you can see all of those different bottles, and at least the one we have has 24 bottles that can be deployed from the ship to be able to collect water samples as the CTV goes down. And we can send this out in a variety of depths. Usually when we're just off the slope, we can reach depths of 3,000 to 4,000 meters. And then when we're off the slope, we can be in areas as shallow as like 300 or 400 meters. And as we send this down to the bottom, back on the ship, we get a plot of the temperature as the CTV goes down in the water. And you can see different masses, different temperatures of water as we get down. And we have been seeing some of that warmer water that Frank was talking about. Not warm enough that I would want to go swimming in, but warm water just above the freezing point that is down towards the bottom coming up that slope. And as we come up with the CTVs, we can deploy this bottle and collect samples of water at different depths. And once we get it back on board, we can go and collect samples of those water that you can see on the left-hand side or the right-hand side of the slide, and then analyze those later. And I think it's really cool because I didn't realize when I first got on the ship they deploy this massive thing out the side of the ship. The huge door just opens in the side of the Homer, and the CTV goes out over the side and down. And we have some amazing marine technicians on board. They're the ones that deploy the CTV that are strapped into that room. So in case we hit a wave or something, they don't end up going out with the CTV as well. All right, I'm going to head to the next slide. And Janet, you guys can still hear us okay?
Yes, I would like to ask some questions if that's okay. Over.
That's fine. Let's hear some more questions.
Okay, question number 1 coming from the aquarium is, how many hours of sunlight do you have currently?
Right now we have about 8 hours of sun. Oh. Right now we have about 8 hours of sunlight, but we are still on the Hobart, Tasmania time zone. So as we're traveling, we're actually moving through several different time zones along East Antarctica. So our day and night is a little bit off. The sun usually doesn't rise until about 10 or 11 a.m. for us. But the time and the amount of sun we're getting is a little bit different for all of us anyway. Ships run 24 hours a day, and we'll talk about this a little bit more later in the talk when we go on to ship life. But different shifts, we're working around the clock. So some of us are up at 8 a.m., some of us are up at noon, some of us are up at 2 p.m., some of us are up much later in the day. And Janet, can you repeat that next question for us?
Yes, the next question is from Lucy, and she would like to know, do you stop the ship to collect measurements? I think you were talking about the CTV. If so, how long are you in one place? Over.
All right. So for the multi-beam, we actually do the stopping as we're moving. And we'll actually stop the multi-beam when we're in one place because we don't want to just keep measuring the same area of the ocean floor. But for the CTV, we do have to stop the ship to deploy it. And it depends on the depth. So we've done some short ones in 300 meters of water that only take about a half hour to do. And then we've done some deep ones, like in the 4,000 meters of water. It's over a mile deep that took us about 4 hours to do. All right, any more questions, Janet?
Yes, we have one more question and then we'll carry on. From what you've found so far, how fast is the ice melting? And this comes from the aquarium. Over.
So this is Frank, so we actually don't measure this directly. So we basically putting parameters that then the people who do the modeling of how the ice melting can use for that we cannot really, from the ships, we really measure how quickly the ice is melting. We can measure the depth of the water, we can measure the temperature of the water, but a lot of the melting of the ice is have to be done from the ice or from satellites that actually measure the thinning of the ice.
So there are a lot of different science teams that end up working on a huge project of such big scale as this one, and it's a great way for lots of people to be able to use that data all together in one place to compile different models of this and to create projections for the future of the speed of potential melting or potential sea level rise and impacts later on. I hope that answers their question. Do you have any more questions for us, Janet, before we head on to our next slide?
Yes, one more question that came up about multi-beam from the aquarium. What is the range of the area you are measuring with the multi-beam? And then we will go to your next slide, 15. Over.
So the range of multi-beam ends up depending on what depth of water that we're in. So as we send sound out from the multi-beam, we actually send it out in an angle. And so if we send it out in an angle, if the water's really shallow, we'll only measure a couple 100 feet or so across. But as we go into deeper water, that angle covers a much wider range of ground underneath us. So it depends on the depth of water that we're in.
Okay.
Yeah, like
go ahead.
3 times the water. That's 3 times the water, or up to 4 sometimes. So if we are in 1 mile of water, then we can measure it somewhere between 2 and 4 miles at the same time with one source. If you're only in 200 meters of water, then we only measure like half a mile or something.
All right, Janet. More questions?
No, we're ready, and I'm on slide Research Techniques, Karsten Cores. Over.
All right. So we haven't done any of the Karsten Cores yet, but these are another great way to learn about what is happening down at the bottom of the ocean and things that have happened in the past. And once we find some areas with some sediment, these are some techniques we'll be doing. A core is basically we're taking a sample, almost like going back in history. We send the collection device down into the soil, and it functions using gravity. It goes down deep into the sediments on the bottom of the ocean and collects a sliver of that we can bring back up onto the ship. And as you go down in distance or down in depth into the soil, you go back in time because the sediments that were on the bottom were deposited long time ago. The ones on top not as long ago. And we can compare and look at those different sediments that are in this core sample that we've taken to see what happened in the past. Did glaciers come through this area and deposit sediments? When did they come through? And be able to see the past activity that's happened in this area. So when we find some areas where some good sediments have collected out here, we will be taking some cores as well. All right, next slide, we will be heading to life on board. So those are some of the different techniques that we've been doing. We have been doing multiple CTVs a day, usually at least one, sometimes two for a single day. We have been doing Multibeam. So the Multibeam, the only time we do it off is when we're supposed to do CTVs. And these are all big incidents that help us as a cycle until midnight, and I work with Multibeam there, collecting data and editing data, and then we get, oh, go ahead, Janet.
So that last little bit when we changed to life on board and you were just talking about CTVs and stuff, you broke up quite a bit and you were very staticky. Can you repeat kind of what you just stated? Sorry. Over.
We're doing a lot of CTVs. We've been doing at least 1, sometimes 2 or 3 a day. And we have been running the Multibeam 24 hours a day, 7 days a week, only stopping for the CTVs. So we have been constantly collecting data since we have been on this ship. I have my shifts that all close and help out collecting data, working at the Multibeam until midnight, and I also help out with collecting water samples and preparing the CTVs. And as I was mentioning, life on board the ship is 24 hours a day. So the science team tends to work in shifts of either midnight to noon or noon to midnight, with those other 12 hours off for us to do what we like. The crew has slightly different shifts, and Frank, as lead scientist, has a slightly different shift as well, so he can overlap all of us. And life on board is very comfortable. If you can take a look at the top left-hand side, you can see what our cabins look like. There are 2 bunks. We got a lot of space in the bunks, and lucked out on this research cruise. We don't have roommates, so we each get a room to ourselves. And In our free time, there's a lot available for us to do. There are a couple lounges on the ship. There's a foosball table. There's a ping pong table. We've got a ping pong tournament going on right now. The ship can easily house about 19 scientists, and there are fewer of us for this team, so we've got a lot of space. There's a gym that we can go work out in. Usually try and hit that once a day, but probably not working out as hard as I would at home. And keep us very well fed. You can take a look at our galley that we have available to us on the top right-hand side. And there's several different meals. Since it's around the clock, we have breakfast from 7:30 to 8:30 in the morning. Lunch from 11:30 to 12:30, dinner from 5:30 to 6:30, and then midnight rations from 11:30 to 12:30 again. So sometimes you wake up for breakfast and you're actually at the dinner meal. And you can see the galley that's right below that. They always have snacks available for us, so we can go in and snack anytime we want. And at the start of the cruise, you end up with a lot of really great fruit. We had amazing produce. We had lots of fresh fruit, fresh mangoes, more fresh mango that I could eat. But by this weekend's produce, we still have really delicious food, just not nearly as much lettuce or fresh fruit that's available. We've gone on to the stuff that lasts the longest, and unfortunately, no more fresh mangoes and fresh oranges for us. All right, if you want to head on to the next slide, Janet.
Yeah, and we have do you want me to relay questions, or do you want to do the slide and then we do a question? Over.
Let's start with the questions.
Okay, so there are several about, let's see, we have a science one from Jeffrey. He would like to know, do ice streams have names like you would give a glacier? And then related to that, do the ice streams become glaciers? Over.
Yeah, this is Frank. So most of these, I start with the second part. So most of these ice streams are actually glaciers in a sense. The only difference is that there's not like an isolated single glacier, but they're like all connected in a big ice sheet. So a lot of them actually call like the Totten Glacier or the Frost Glacier, Biddle Glacier, and the Pine Island Glacier. So they usually have, pretty much all of them have names by now, and mostly called glaciers. I mean, there's a couple they call like the Williams Ice Stream, and they're a little wider, but usually they have names, and they are kind of the terms glacier and ice are a little bit interchangeable here. The difference from a normal glacier and the mountains is that they're all connected past the big ice sheet.
Okay. All right, Janet, next question or the second half?
Yes. No, Frank answered that question. The next one is about life on the ship, and I'm looking for it now, but it related to playing ping pong on the ship. Is it more difficult than on the land? And then the second question is about the size of the ship and the icebreaker, which I didn't know if you were going to cover in that next slide. Over.
All right. Yes, playing ping pong is much more difficult on a ship than it is on stable land, because there's a lot of rocking and moving back and forth, and it just makes it more exciting. But on the ship, since we don't really have internet, we don't have TV to watch, we don't have movies, we have to find out a way to make our own fun. And playing ping pong on a ship's exciting. We've got the tournament going. Sometimes people dress up in costumes for that. So it makes it very interesting. The ship itself, the Icebreaker Nathaniel B. Palmer, we are an ice-capable vessel. We can go through a lot of different kinds of sea ice, but I remember getting this question on my blog too. Some types of ice we can't go through. So a lot of the sea ice is thinner. We can make it through no problem. We can even go in and break some of the thinner sea ice. But some of the ice that's attached to the continent, even the sea ice, can be meters and meters thick. So we can't get through that. We can usually make it through ice that's about 3 to 5 feet thick. But any thicker than that, and we can't get in all the way. Were there more questions, Janet?
Nope, we are good to go for your next slide on, let's see, it was life after board and it has you in a Gumby suit. Over.
Awesome. So on a vessel in East Antarctica, we are very isolated. We've got the satellite phones, like you can see, and we have access kind of to email. We can send emails out, but they're not instantaneous. There's some lag as the ship finds a satellite to send them out with. And that means that our safety is a very... Are you still there, Janet?
I'm still here, Dominique. Go ahead.
Okay. Safety is a very big deal out here. We have weekly fire drills, and in a fire drill, you have to bring basically your ditch bag and everything that you would need to abandon the ship if you had to, and that's what the immersion suits are. So that funny Gumby suit that you can see me in there is something we take to our weekly fire drills. And when you put one on, it's basically like a giant wetsuit and personal flotation device or life jacket all in one. And that's what we have to wear if we were to abandon ship out here into water that is below freezing. And besides doing the weekly fire drills, we manage to still find time for a lot of fun, even with 12-hour shifts doing science all day long. The crew on board and the staff there find a way to plan lots of fun activities for us. So some people bring movies, and we have movie nights regularly. I've been able to catch up on a lot of the Oscar-nominated movies while we're down here. I mentioned the ping pong tournament that we have. We also have foosball available, and we find for Easter some of the Marine technicians organized an Easter egg hunt for us and around the ship looking for Easter eggs. And we've also been able to have some fun with the science that we're doing too. When we did the very deep CTV down to 400 meters, we sent styrofoam cups down, and the pressure of the water down at that depth actually compresses all the air and pushes air out of that styrofoam cup. So on the bottom left-hand side, you can see us shrinking cups during our CTVs that we're doing. And we also get to spend a lot of time up the bridge or out on deck, bundle up really well. Sometimes it's -50 down here. And head outside and do some wildlife watching or looking at glaciers. We've had some minke whales pop up that we've gotten to see. We've had emperor penguins and Adelie penguins that are on ice floes near the ship. We got a lot of birds, albatross and petrels, and we've had some sea seals too, including some wettle seals and rock seals, which are a pretty rare sight to get to see. And it's gorgeous down here. You can see huge expanses of ice and tall icebergs taller than the ship floating by. Do you have any more questions for us right now, Janet?
Yes, we do. That Gumby suit sparked a few questions, and one person, Mayu, would like to know how long could a person survive in one of those Gumby suits? And then related to that, I guess, Jeffrey would like to know, do you have to wear sunscreen in Antarctica? Over.
Very good question. When I was trying on the Gumby suit, they didn't tell me how long I can survive in the Gumby suit, just long enough to be rescued. But if we were to fall in the water without the Gumby suit, they warned us we don't have much time at all. The Gumby suit is mainly intended for us to get to the lifeboat safely and get in the lifeboat safely. With the next, can you repeat the next question, Janet?
Yeah, they wanted to know if you have to wear sunscreen in Antarctica. Over.
Yes, sunscreen is highly recommended here. I was out yesterday. It was bright and sunny, and I could almost just barely feel the warmth of the sun on my face. However, there is still a thinner layer of ozone down here, so it's good for you to wear sunscreen if you can. I brought 100 SPF. That might have been a little bit of overkill, but I just wanted to be sure. More questions, Janet?
Yes, the aquarium has had actually a couple. One is about your Gumby suit again, and then I have another question about wildlife. The first one about the suit is, what is the rescue plan and who will rescue you? Over.
That's a very good question. So we also have man overboard drills, and everybody is supposed to help out with those. If you see someone go over, you have somebody keep an eye on them constantly, and then the crew, who are incredibly well trained, maneuver the ship to a point where they can come get you out of the water. So the crew are basically, they are our life support while we are out here, the crew that runs the ship. All right, next question, Janet.
Okay, the other question from the aquarium was, were there any cetaceans, and what kind do you find?
All right, there are lots of cetaceans that live in East Antarctica. And cetaceans are animals like our whales, dolphins, porpoises, stuff like that out here. And you can find a couple different kinds in East Antarctica. There are the mysticetes, or the baleen whales, and then the odontocetes, which are the toothed whales. And out here, normally there are blue whales, fin whales, Bruce whales, sei whales, orcas, different kinds of dolphins, different kinds of beaked whales. But it is almost winter down here. It's late fall. Ice cover is moving out considerably. And the only whales that we've spotted so far are minke whales, which are a smaller baleen whale. And they're fun to watch, very curious. They can come up and sometimes take a look at the ship, but it's hard to get a good photo of that because they just come up, breathe a few times, and then disappear for a while. All right, next question, Janet.
Yes, back to survival in Antarctica. Do you practice the man overboard with an actual person in the water? Over.
We do not practice putting people in below freezing water. The man overboard drills are more for what you would have to do if you were off the ship. So we do not sacrifice anybody just for the drills.
Okay, Dominique, I think
go ahead with the next question.
That's it for the questions at the moment. So now I'm on your next slide about getting involved.
Okay, wonderful. So yeah, I was just finishing up with penguins. We've got a lot of Adelies and emperor penguins out here on the ice floes. And then if you head to the next slide, we are running a blog. Both Frank and I have blogs that are available. If people are still interested and love to follow us, we still have a lot of science that we're doing out here. They can follow our blogs online. I'm also posting the blogs to Facebook and to Instagram and Twitter. If people are interested in following along there, that's a great way to learn a little bit more about the firsthand science that we're doing. And there's lots of ways to explore more about the science that we're doing down here, as well as other Antarctic and other polar science that's going on. Going to PolarTrek's website is a great place to learn more about the different science that's being done, and a great jumping off point to figure out topics that people at the aquarium might be interested in. And there's a lot of fun activities to try your hands on at home and do a little bit of the science that we're doing here in a home setting. And it's always important to be able to just do your part for this. Learn more about these kinds of topics and help preserve the ecosystem that we're down here studying right now. And then I'm going to go ahead and pass it back to you, Janet, and see if you have any more questions for Frank and I to answer.
Okay. Yeah, we do have another question that's just come up from Jeffrey. It says, what were you expecting to learn from the research on the trip? And did you find out something different from what you expected? Over.
This is Frank. So there was a little, as mentioned earlier, so large areas of the Eastern Arctic area that we are in right now have not been really studied for details of water depths and warm water so much. So we were hoping to really find out, and we've done in part of this, how deep really the shelf are, and if it's really, warm water already on the shelf, nearby the shelf, that maybe if the ocean is warming further, then could go onto the shelf and reach the glaciers. And so there were, some areas where we found that the bathymetric, the seafloor maps that existed are not quite correct. So this was some new things that we found, and we did find some warm water in some areas, and in other areas we didn't find that much. So we have to go back, to our offices and after the cruise and analyze the data in detail to find out. But really what's mattering. So it's usually a two-part thing. You go on the cruise, you collect a lot of data, and then you go back and analyze this data in detail in the next couple months and years at home. We collect a lot of data, so that needs a lot of time to look at those in detail.
Yeah, when you're collecting data 24 hours a day, it's hard to have time to sit and analyze the data too. So there will be still a lot of work to be done once we get back from the trip as well. Go ahead, Janet.
Okay, thank you, Frank. We have another question from Betty, and she wants to know, have you found any polynias, and if so, what have you learned? Over.
So those who don't know, so polynias are areas of open water in front of ice streams and glaciers, ice shelf, surrounded by ice. And yeah, there are a lot of polynias. We found a couple here. The thing is that we're actually very late in the season, so it's already April. So a lot of those areas are actually freezing over right now, so new sea ice is forming. And so we have not been able to get into these polynias. A lot of them are only open during the Antarctic summertime, which is usually December, January, February to early March, and then late March, April, the time we are here now, and a lot of those are starting to freeze over. And that's also the reason why we see a lot of new sea ice forming all over the areas. Thanks.
I'm going to add something to the Polynia question too. As someone who's never been to a Polynia before, I got to learn a lot going into them. And there's a couple different, there's two different types. There's one where water upwells and melts ice, and then there's other ones closer to the continent where it's the katabatic waves, the really, really strong winds that come off the continent blow further off the continent, creating super cold, salty water. So some of these Polynesians, one of the types of Polynesians is actually really important for driving the deep water circulation of the ocean. You get really cold, salty water falling deep into the ocean, driving ocean circulation. And I learned going into this that they are incredibly cold and incredibly windy. When we're going out in Polynia, they were like 60-mile-an-hour winds or faster. And it's hard to go outside of the ship when you're in a Polynia. Go ahead, Janet.
Okay. Yeah, great. Thanks. We do have, I just wanted to relay to you, Dominique, that as we get some of these topics that are coming up, Sarah is posting related journals. So she's been sharing with everybody the related journals. And the next question is from Christopher. With regard to warm water, are you observing a rise in water temperature at all depths, or is there something like a thermal inversion occurring, leaving a warmer layer of water at lower depths? Over.
Well, so when we look at the warmer water comes from the Southern Ocean usually, and it's very salty, so it is usually denser than the water on the shelf. Like this has less salt because it has a lot of meltwater from the ice in there as well. So we see different like a temperature inversion, if you want, where like the warmer temperature is sitting low, colder temperature water, and there's it varies along the area. So one thing we are looking at is how it varies from one ice stream glacier system to the next. And once we have all the data together, we're going to look for different patterns, how these things are changing. And then we also might be able to compare our data to some measurements that have maybe been done 10 years ago to see if there has been a change over time. But of course, with a short time frame that we are here, just like a month and a half, we cannot really observe like time changes on this short time span. But if we go back and then later compare to older data, we might see if there has been a change in temperatures this time.
All right, and as we do the CTVs, you can actually see a temperature profile of the water going down. And in some areas we can actually watch as the CTV goes down, the change in temperature, and it looks almost like layers on the graph that the CTV produces. And we're creating, actually one of the things that we're doing for the aquarium and for PolarTrek is creating some lesson plans that are hands-on activities for people to do. We'll be introducing them in the aquarium speaker workshop that we have coming up. But we actually have a lesson plan in the works right now on that exact topic because it is such an interesting feature. All right, go ahead, Janet.
It looks like, Dominique, that we have got all the questions, and I'm just waiting to see if anything else comes up. Over.
All right, well, we are waiting to see if there are any more questions. I want to give some huge thank yous to people that are involved with this. So first of all, thank you, Janet and Sarah and PolarTrek, for arranging all this and making this all happen. This has been an amazing experience to be able to come down here and help Frank and his team with their research. And a big thank you to Frank and to Lamont and to NSF for funding all this and getting us on here to be able to do this work. And I also want to say a huge thank you to people back at the aquarium. Thank you very much to Chris and Jim and Ed and Kirsten all back at the aquarium who are getting all of these connections set up and making it possible for us to talk to you guys at the Earth Day Festival today. This is a great opportunity to talk to you from over 8,000 miles away. And I also want to go ahead and say hi to a few people back home, and hi to Jeff and Mayu and my parents that are out there listening too. So any more questions or anything else for Frank or myself, Janet?
Yes, right. Your fan club is responding to you. They're saying, thank you, this was great, thank you, lots of smiley faces. One question for you from the aquarium is, what's your favorite thing you've seen so far, seen or done?
Seen or done, that's really hard because this is a trip of very new experiences. I haven't been to Antarctica before, and just getting to go outside and see the huge experiences of ice that are out there, and learning about there are dozens of different kinds of sea ice and how they form, and actually getting to watch all different kinds of sea ice form is very extraordinary, and it's just such an amazing landscape down here. It's awesome. Though getting to see a Ross seal, which some of the people who've been down here dozens of times before haven't seen before, was also pretty cool. But I'm keeping my fingers crossed, and I'm saving my most amazing experience for hopefully when it's finally not cloudy, we'll get some southern lights down here. And I'm hoping that I will get a chance to see those before we take off, and I'll leave my most amazing experience when I get to see that.
And I just want to relay to Frank that he also has his own fan club online here as well. There's a family, Thomas Richardson would like to say, thanks Nikki from the family in Lakewood, and I believe there was a wolf gang on earlier. And there's some others that know many of your team members. So just to let you know that they all are saying hi to their family and friends as well.
Yeah, and thank you, and greetings to everybody, like my family at home and whoever's listening in. So and who know me, so great. And thank you for sending Dominique along on this trip. She's a tremendous person, really helping, with our work here as well, and bringing all the science to the classrooms. That's great to have.
Okay. Well, I think that's it. I think we are amazed at how great the satellite connection has been. I think it's a record, Dominique, so good job to the captain for making the ship go in the right direction for us. We will be archiving this event, and it will be posted on the website for everybody to access at a later date. And we really want to thank the aquarium for drawing in people to listen to Dominique. We hope you guys have a great Earth Day event, and everybody else that is out there have a great weekend and celebrating this wonderful planet that we all live on. Thank you, Frank and Dominique, also for the presentation and the great explanation of science. Very interesting. So good job, everybody.
Thank you, Janet. And if Sarah's on there, thank you, Sarah, for putting all of this on. And I just want to say one last hello and goodbye to everybody that's following at the aquarium. It's great to get a chance to talk to you guys today. And if you guys have more questions or want to know more about the research that we're doing and life on board, I highly recommend going out online and checking out our blog. We go into a little bit more detail all of that. Janet, we will hang in for a little bit longer in case you get any more questions. But otherwise, thank you so much to everybody that's joined us today. Thanks to our families for supporting us, and thank you to everyone at PolarConnect and at Cabrillo Marine Aquarium. And we will say goodbye for now. Janet.
Okay, great. I'm going to stop the recording, and then I'll let everybody, family and others that are in there and want to say hi, you can all pipe in on your mics here. Just let me